I'd like to welcome you to today's class. Today we want to learn how to convert an IP address into binary. So we have an IP address on the board. This is IP version 4. So we have two types. We have version 4 and then we have version 6. But then this is version 4. So how do we convert this in version 4, which is in IP version 4 to binary? Let's quickly do that. But before we do that, what we need to know is that IP version 4 can be represented using 32 bits, okay? And with the 32 bits, we divide it into 4 parts. So 32 divided by 4, that is 8, meaning that every point must have 8 bits, okay? So the decimals or the points here are 1, 2, 3, okay? And the numbers we have first number, second, third, and fourth. So we represent the fourth one with 8 bits, we represent the 66 with 8 bits, represent 107 with 8 bits, represent 192 with 8 bits. That's what we do. So each of them will have to take 8 bits. Okay? And the bit simply means the binary numbers, that's zeros and ones. Okay? So if we say 5 bits, it means that 5 binary digits. Okay? If we say 2 bits, it means 2 binary digits. So we have to convert 5 to binary, we convert 66 to binary, the right or that's exactly what we are doing. It's not difficult. So let's quickly do that. There are so many ways you can use to do that, and the way that I want to use to solve this is, first of all, since we have to represent each of the digits here in 8 bits, there's a certain formula we use so that we get to know where we have to end when we are writing the numbers in the form of bits. So we use a formula that's 2 exponent n minus 1, where n is the number of bits we want to represent the number in. So we want to represent each of the numbers here in 8 bits, so n will be equal to 8. So we have 2 exponent 8 minus 1, and 2 exponent 8 minus 1 is 2 exponent 7. So when you press 2 exponent 7 on the calculator, you have 128. So that's what I'm going to use to solve my question. Good. So it means that we are going to start our table from 128. Then we now divide 128 by 2, we get 64. We divide 64 by 2, we get 32. We divide 32 by 2, we get 16. We divide 16 by 2, we get 8. We divide 8 by 2, we get 4. We divide 4 by 2, we get 2. We divide 2 by 2, we get 1. So it's going to be like this. Okay. Okay, so it's going to be like this. Okay, so now what we'll just do is that we'll put our 192 here. The next number after 192, we have 107. After 107 is 66, after 66 is 5. So this is another table that you can use to convert from base 10. That is the dotted decimal. So the dotted decimal is the same as base 10. So the numbers here are in base 10. So we just convert them to base 2, which is the binary. So to do that, we look at this. So 128 divides 192 just once with a remainder. So let's see what that remainder is. So 192 minus 128, that's 64. So the remainder is 64. 64 divides 64 one time with a remainder of 1. Right? Okay, without any remainder, because 64 divides 64 1, so with no remainder. Yes. So another way to check whether what you've done is correct is just to add this to that. So you add 128 to 64 and see whether it's equal to 192. So 128 plus 64, yeah, that's 192. Good. So 128 divides 192 once, remainder 64. So 64 divides that 64 once with no remainder. So this is what we are going to have. Now 107, 128 can't divide 107, so we'll put 0 here. 64 goes into 107 how many times? 64 goes into 107 once with a remainder of 43. 32 will go into 43, or 32 will divide 43 once. So once, remember 11. 16 can divide 11 to give a whole answer, so we put 0 here. 8 divides by 11 once with a remainder of 3. 4 can divide that 3, so we put 0 here. Now 2 divide 3, 1, then 1. So it means that if we presented 107 in base 2, if we presented 192 in base 2. Now we go to 66. 128 can divide 66 to give a whole answer. Yes, but 64 can. So 64 divides 66 once with a remainder of 2. So this can divide the 2, this can. 2 divide 2, 1 with a remainder of 0. 5. So this can divide 5. But 4 divides 5, 1. So it will be like this. So this, we've been able to convert all the numbers from the decimal, from the dotted decimal of the base 10. And now we've written the answers in the binary. So we say binary because we are using only 2 digits. That's 0 and then 1. We won't use any number above 0 and 1. Okay? Good. So we are done. This is just what we want to do. So the only thing is that we have to write these answers we have in this form we have here. Okay? So let me pull it down here. Since 192 began, we have to look at the binary for 192. So 192.107.66.5. This is equal to, so 192, the binary for 192 is 1, 1. The rest are zeros. So 1, 2, 3, 4, 5, 6, 7. Sorry, it's supposed to be 6. So 1, 2, 3, 4, 5, 6, 7, 8. So that, you remember we said that for IP version 4, we present the IP numbers. Each of the numbers, you have to present them with 8 bits, okay, or 8 digits. So we presented 192 with 8 digits. The 107 must also be presented with 8 digits. So we leave a space, a very small space, 0, then we repeat this. So 1, 1, 0, 1, 0, 1, 1. Is that it? So 1, 2, 3, 4, 5, 6, 7, 8. So we are done with that one. We come to the 66. We represent it with 0, 1, 0, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. So it's like this. So 1, 2, 3, 4, 5, 6, 7, 8. So we are done. For 5, we do the same. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Then 1, 0, 1. So this is the answer we have. So we've been able to safely convert the IP address from this form into the binary. Okay. So this is how we solve it. Any other IP address that you know, you can solve it this way. But there are so many ways you can also solve it without using this table. Just that I see this table to be a much simpler way of solving the question. Now, we also want to consider a point or a question whereby we've been given the IP address rather in the binary, and then we have to convert it from binary to the dotted decimal. How do we do that? So the next question, we will solve a question where we have an IP address which is in the binary, and then we have to convert it to this form. Okay, so I'll put the link of this video in the link of the next video so that you can access that. So thank you very much for your time. Stay tuned for more educational videos. If you have any suggestions, any comments, you can let me know in the comment section below. I really appreciate your suggestions. Thank you. Bye bye.